A very cool, crisp morning out there, and with clear skies, that's given us some great conditions for aerial photography. However, we have a very powerful system moving across New England. Due to the high winds, they're reporting many power outages. Due to the high winds, they're reporting many outages across Maine. Over 100,000 customers without power today. Here's a look at the METAR observations over the past day at Portland, Maine, which is in the south part of the state. Now, it's good to be able to understand how to decode this stuff because this is the actual observed data. You can get this at Aviation Weather Center. Just put that in a search engine and you'll have that come up. So what do we see here? We're looking backwards in time chronologically from the current time back to overnight. One thing that really stands out is a wind shift, and I'm looking at the wind data right there. You can see the numbers go from hundreds at the very beginning, 170, 160, to 200 to 230, 250. So that's going to be a frontal passage. And it looks like that happened right around here, which means that was at about 1330 Zulu, which is about 9:30 in the morning. Now you notice also there's a pretty good gust there, 46 knots. That's going to be about 52 miles an hour. And another thing that's kind of interesting is the sustained wind was only 15 knots. So that's a very variable wind. Typically, we'd expect to see 30, gusting 46, something like that. So, yeah, this is a very volatile system moving through. Lots of gusts, and that would indicate to me that there's probably some evaporational cooling, virga, and stuff like that coming down to the surface in an unstable atmosphere. And there's a quick look at Bangor, which is about 150 miles maybe to the northeast. It's closer to the center, the east central part of the state. 44 knots, so they got wind up there too. And let's take a look at Mount Washington. That's always a crazy place. They got a gust to 90 knots this morning, around 8 a.m. Eastern. And you can see the conditions were really bad up there. It was above freezing, nice toasty 55 degrees Fahrenheit, but it was very foggy, and they were just socked in with overcast. And you can see the temperatures tumbling through the day down to about 39 Fahrenheit. So pretty obvious where the front came through. This is up near the 700 millibar level, so this kind of gives you an idea what's happening in the mid-levels. You can see that frontal passage right around here, where it dropped from 13 to 10 Fahrenheit, and also we got this wind direction shift. So it looks like the peak winds were right before the front passed, and then the winds kind of tapered off a little bit as those west winds set in. All right, so what's going on? It appears we have a very strong frontal system moving through Maine there. We've got this little bend in the isobars that would be indicating probably a rapidly developing baroclinic low. And we might have seen some very strong localized pressure accelerations right out ahead of it. Very strong westerly flow across the Appalachians. And as we go further back, we've got this feature here. And a lot of people might want to draw a front there. But we have to be careful not to drop a front in every single trough that we find. If I look at the air mass in here, Ohio, Pennsylvania, we can see the temperatures are in the low to mid 60s and dew points in the mid 40s. What do we have out here in Minnesota? Temperatures in the low to mid 60s and 2 points in the 40s. That's not an air mass change, so you're not going to want to draw a front back here. This is probably the same air mass, and I think there's probably a very slow transition to a more continental air in the Dakotas, but not enough to put a front between the two. So the one thing we can be sure of, there's going to be at least 1 to 2 days of strong cold air advection in the northeast, and then we should see the higher pressure out to the west start to move in. The satellite, as we've seen, showing very stormy conditions. Again, cold air advection. What's happening is you're getting strong modification of that air mass. This is very cold air from northern Canada, and as it moves southeast, it modifies across the warm terrain. And that creates more of a cold over warm situation, with the main emphasis being on the warm at the bottom. Due to the heating, the warm ground, it's still September, so you get a very unstable column in the lower atmosphere. We could take a look at that on the high-resolution rapid refresh. So what we'll do is we'll go to this area here in Ontario. I guess that would be just west of Ottawa, and we'll pull up a forecast sounding. And what we see here is the elapse rates are almost dry adiabatic up to about 8,000 feet. That's very unstable. And due to the dew points being quite high, that means you're going to rapidly fill up with cloud material between about 4,000 and 10,000 feet. So no wonder there's a whole bunch of stratocumulus out there. You can also see the low tropopause. That indicates that you're way back in the cold air. And what's happening graphically on the Skew-T is we're warming this part of the sounding, which makes this entire area here steeper. In other words, we kind of trend more and more like that. It doesn't really get like that. You can't have a slope that far over because that exceeds the dry adiabatic rate. But the general idea does apply there. And the way the atmosphere kind of works that out is as you warm the lowest levels, the warm air gets transported up through convective cells, and the cold air ends up sinking to the ground. And that generates this very thermally active cell. You get mixing, gusty winds, and that kind of equalizes the lower layers. So you can certainly keep adding heat to the bottom, but you're going to get strong gusty winds and big, scary stratocumulus clouds and turbulent conditions as the atmosphere works that out. There's a look at the southeastern U.S. this morning. Run that satellite loop forward, and we can see that the tail end of that front is extending down into Florida. Pretty dry, cool conditions across the rest of the U.S. Let's check out the surface map. That cold front has just about cleared most of Florida. You can see the gusty north winds back behind that front. And as we move out to the west, we get into that ridge. This is an old polar high that moved across Texas yesterday and is pushing southeast into the Gulf and back further to the northwest. This looks like a fresh outbreak of cold air that has modified substantially. And yeah, as we go further down that boundary, I do see maybe some temperature contrasts, but I'm not really sure I want to put a front in there just yet. Now let's take a look at some Skew-Ts. I think it's really important as a forecaster to be familiar with these tools. And if you stick around and watch this channel, we're going to continue doing this over the next month or so. So we're going to start out looking at around the Lakeland area of Florida. That's going to be kind of in here. Well, I don't know if that's Lakeland, Orlando. Yeah, let's go with that. I'm going to find a Skew-T on the high-resolution rapid refresh. You can see that that's going to be back behind the front in that area of north winds. So we'll click on the map right there and see what comes up. And there, yeah, we do see the front in the wind field. See how we have a very shallow layer of north winds, and then when you get to this plot right here, it transitions to southwest all the way up. If that's hard to read, you can look at the photograph up at the top right. There's 0 kilometers, that's near the surface. There's one, which is going to be about 3,000 feet up. So that's going to be calm winds. And then we start picking up the northeasterly, or I should say southwest to northeast flow up above 3,000 to 4,000 feet. So that gives you an idea of how deep the cold air is. It's about 4,000 feet deep. So we're talking about this layer right here. That means the top of the cold air mass is about right in here. And then above that layer, looks like we have some stratocumulus. There's probably a little isentropic lift in there, little elevated convection spreading out beneath this inversion. And that's where we get up into the free atmosphere itself. Or I should say that's the elevated mixed layer, and that probably has its origins from Mexico or the Caribbean. And then we do see a layer of cirrus up aloft. Let's check out the trajectories there at Orlando. Well, there you go. There's the trajectories at Orlando. This is the NOAA High Split, HYSPLIT trajectory tool. You can find that in a search engine. And I think this is kind of an underutilized tool for forecasting. Here we can see the origin of the air masses pretty clearly. The red, that's going to be the parcels ending at 500 meters, which is about 1,500 feet. We can see that that's coming from northwest Canada, or I should say western Canada, the Gulf of Alaska. So that's part of that Pacific system, and the parcels have moved from there into Florida. And the remainder of the air, 3,000, 4,000 feet and up, is coming from the Caribbean. So that's part of the tropical air mass. So that's a good way of visualizing where these different air masses come from. Let's do another. Let's go into Texas. We'll try Waco, which is located about, that's going to be right in here. And what do we see there? We look at the overall pattern. We see that there's high pressure in the Gulf. This is that old receding polar air mass. But the temperatures are rapidly coming up, getting that strong surface heating. So what we see here is that the air has very likely a origin from Western Canada, but it's modified quite a bit. And we'll drop that Skew-T right on there. Yeah, that's going to be Waco there. And we can see that there's just southwest winds transitioning to northwest winds. Not particularly strong. We also see that the lapse rates are very steep in the lower levels. That tells us there's probably some air mass modification taking place, especially with that dry air, the origin from Western Canada. And let's look at the trajectories. And as we see here, all of the points arriving in Waco in the lower levels are coming from Western Canada and the Western U.S. That blue line, that's one of the parcels at 3,000 feet there. There's going to be a little variation. These reverse trajectories are not 100% accurate, but it's got the general ballpark idea of them originating from the Pacific. So now you have a better idea what you're looking at. That's very clearly modified polar air, influenced heavily by solar heating. Speaking of solar heating, there's plenty of that in the southwestern U.S. Clear skies just about everywhere. Looks like some residual wildfires there in the northern Rockies, and some plumes of smoke coming into Oklahoma and the Panhandles. California not quite done with its wildfire problem, especially up in the north. There's definitely a change from about a month ago. Instead of conditions being dominated by this heat low in the southwestern U.S., they're dominated by this big plateau high across the Great Basin and the Rockies. And that, of course, is the remnants of cold air coming from the Pacific, which has pretty much settled down and filled in the gaps in the valleys. And as a result, we get this light north wind, But that high pressure area is starting to break up a little bit. Also, we have a heat low in southeastern New Mexico. You can see the temperatures there almost up to 90 degrees. Got 91 at Childress and 92 at Hobart, Oklahoma. So yeah, I think some of that trough is probably due to strong heating and the ridging and pressure rises up to the north being caused by the cold air advection and the denser air mass coming in from the northern plains. And another area that might be seeing a heat trough is in the San Joaquin Valley. Temperatures coming up to almost 90 degrees at this hour, and you can see the smoke there on the station plots. So you could probably put in a trough. In fact, let me do that correctly. There you go. That's a trough associated with a heat low. And now let's check out the northwestern U.S. So looking at the big picture, we see a fresh outbreak of cold air coming south, 1033 millibar high across Alberta, with temperatures in the 40s and 50s across the Canadian prairies. That seems to contrast a little bit with this warmer air out in the deserts of Oregon and Nevada. I do see a temperature contrast in the valleys of British Columbia and Idaho, not so much in the Rockies. See, there's not very much of a temperature contrast from east to west. And the satellite imagery showing pretty much clear skies. There is a little band of altocumulus, some gravity waves within that across Montana and Wyoming. But other than that, pretty clear. It's hard to believe I filled up almost 15 minutes on a day where there's really no weather except in the northeast U.S. So why don't we take a quick peek up in Canada and see what's going on. Well, there you go. That high pressure area extends all the way up into the high Arctic. So yeah, we're bringing down cold air from some very northerly latitudes. And two very active low-pressure systems, one there in Quebec. That's a 985 millibar low. And out in the Gulf of Alaska, it's kind of off the frame there, but a spider web of isobars. That looks like it's a 970 or 980 millibar low, probably around Kodiak, way down there at the start of the Aleutian Islands. And temperatures coming down, they're not particularly cold. That's one reason we're not in the deep freeze in the Northeast. These temperatures are pretty seasonal across the Northwest Territories, but they are coming down day by day, week by week, as the solar angles get lower and lower. So that'll do it for another edition of Forecast Lab. Just as a reminder, the giveaway of Instability Skew-T and Hodograph Handbook to one lucky new Patreon supporter, that ends tonight. So you'll have until, say, 6 a.m. tomorrow morning to get in on that. And to do that, follow the link that you see here, and that'll take you to our Patreon. So tomorrow we'll announce who the winner of that is and do that random drawing. Okay, hope you all have a good Wednesday evening, and we'll talk to you tomorrow. Bye-bye.